But no, that seems like the right order. First you gotta talk about 1, and then when you try to talk about 2, the next thing you know, you've got 3 and 6. And then you've got to stay on the topics of 3 and 6 for a long time. But then from 6, like I said, you can get 12 right away. But 12 is still just another facet of 6. 12 is 2 6s, and we already had 2 and we already had 6. So that's the place to start. Now, getting to 4 would be the next step. And 4 is the square, or is the square grid that we operate under. But it just goes to show the complexity of the level 4. We've reduced it to simplicity in our own lives, but what I'm trying to show is that the truth of the matter is that 4 is really 2 6s. It's twice as complicated as you think it is. You turn a hexagon 30 degrees, you look like it's turned 90 degrees. That's the big trick. In order to make a hexagon look like it's turned 90 degrees, you need to only change it 30 degrees. So, in essence, a 30-degree change makes it look like a square. So that's the complexity of the square. The square is an illusion. The square is simply a 30-degree rotation. And then 4 is that complicated, but it's still understandable as this 30-degree rotation. It's the number 5 that's so elusive. You just can't seem to arrive at it. The only good way to arrive at it is to take the number 6 and to remove one of its pieces and move into the 3rd dimension, just like this model that we saw before. So that's what I'm trying to express with all of this, is going in this logical order. And like we said, first we start with 1 and then we try to make 2. But upon making 2, we find that in the same instant we've made the numbers 3 and 6. We study 3 and 6 for a while and we find out that the only thing we can do from there is make the number 12. But given 12, all of a sudden we find 4. And we're really happy because we come up with 0, 1, 2, 3, 4, and 6. But where did 5 go? 5 is the trick. 5 it's easiest to get at through the 3rd dimension, but there's got to be a way to stay in the 2nd dimension. But that's the complexity of the number 5. We thought 4 was complicated. 5 is 100 times more complicated. 500 times more complicated.